So example 5, suppose the duration of a particular type of criminal trial is known to be normally distributed with a mean of 21 days and a standard deviation of 7 days. So I know I'm going to need those. If one of the trials is randomly chosen, find the probability that it lasted at least 24 days, sketch a graph and write the probability statement, and then part B, 60% of all trials of this type are completed within how many days? Okay. Let's look at part A. So I'm going to go ahead and sketch a quick graph. So we have a mean of 21, standard deviation of 7. It lasted at least 24 days. So 24 is somewhere to the right here. And we're going to shade it on out. And we know that actually it never touches, but okay, there we go. So we're trying to find this area here, which represents or corresponds to the probability of this this question. Okay, so I am going to go to second distribution, number 2, normal CDF. I'm looking for the area. Low bound is 24. Upper bound is 1 E99 out to infinity. 1 E99. The mean is 21 with a standard deviation of 7. Press enter and we get to about 0.334. So we get a probability of about 0.334. And so sometimes it'll say and write the probability statement. All they're wanting you to say here is something like the probability that a randomly selected trial will last more than 24 days is about 0.334. So for part B, 60% of all trials of this type are completed within how many days? Does not take long. 60% we know is a little bit to the right over here. So this area is 0.6. So when I'm given the area, I know that I need to use the inverse norm. So let's flip over here, second vars, and then go down to number 3, inverse norm. We are looking for the areas to the left of that. We're just looking for this value here, a little bit to the right of 21. So area is 0.6, mean 21, standard deviation of 7. And we get 22.8. That is my value there. So 60% of all trials are completed within 23 days or so. This could also be asked as a percentile. Find the 60th percentile. Okay, which is exactly the same thing. So know that there are a lot of different ways to ask the same question. And that's it for this particular lesson. The last lesson we're going to look at is going to talk about how do we assess normality. We looked at being able to plot this with histograms or dot plots and box plots. We're now going to see if we're looking at raw data, how do we determine if the underlying population is indeed normal? We're going to look at something called the normal probability plot. So stay tuned.